Hello and welcome to another GCSE revision video, and in this video, continuing in the series of Introduction to Probability, we're going to look at experimental probability, otherwise known as relative frequency. Okay, what I'm about to say in this lesson might seem like it slightly contradicts something I said in the previous lesson. I was at college one time and I saw a note on my computer science lecturer's door and it read, "In theory, there's no difference between theory and practice, but in practice there is." In the real world, sometimes reality doesn't always fit nicely into our mathematical way of thinking. In mathematics, we call a die fair if the probability of rolling a number is the same as the probability of rolling any other number. And that's not just true of dice, it's true of anything. If it fits beautifully into our mathematical theory, we call it fair. So on a fair die, if you see on an exam paper a fair die, you know the probability of rolling a 1 is the same as the probability of rolling a 2, 3, 4, 5 or 6. It's all 1 chance in 6. In the real world, not all dice are fair. Some imperfections in the manufacturing process, or perhaps deliberate tampering, can cause some numbers to appear more frequently than others. Again, not just on dice, it could be anything. When we can't rely on theoretical probability, we can conduct a large number of experiments and count the number of outcomes against the number of experiments. When we conduct a large number of experiments, we can estimate the experimental probability by dividing the number of times the outcome we are looking for happens by the total number of experiments we conduct. So in this case of rolling an imaginary dice 1,000,000 times, if the die is fair, we would expect that over enough experiments, the experimental probability would gradually get closer and closer to the theoretical probability. If, however, over a very large number of experiments, the experimental probability deviates significantly from the theoretical probability, we can grow increasingly certain that the die is biased or loaded. So when we conduct a large number of experiments, we can estimate the experimental probability by dividing the number of times the outcome we are looking for happens by the total number of experiments we conduct. In this case, the probability of event A is the number of times an event occurs, or event A occurs, divided by the total number of trials. Okay, let's try an example of experimental probability. I want to have a birthday party on the 2nd of May. Should I organise a dance in a hall or a barbecue picnic in the park? What's the probability that it will rain on the 2nd of May? Okay, looking at the historical weather for the 2nd of May, in 2017 it was sunny, in 2016 it was overcast, in 2015 it was raining, in 2014 it was sunny, 2013 it was sunny, 2012 it was sunny, 2011 it was sunny, 2010 it was overcast, 2009 it was raining, and in 2008 it was sunny. So there were 10 years that we've taken into account, and on 2 of those years it was rainy, so the probability of a rainy day is 2 in 10. And just for completion, the probability of it being overcast is also 2 in 10, and the probability of it being sunny is 6 in 10. Remember, the experimental probability is only an estimate of the true probability. The more experiments that are done, the closer the experimental probability will come to the true probability, but it is only an estimate. Okay, well, so much for the theory. Let's have a go at putting that into practice. Looking back over 50 random GCSE past papers on mathematics, of course, and sample papers, I noticed that in 48 of them there was a question related to probability. Estimate the probability that there will be a probability-related question on my exam. Okay, well, this is extremely straightforward. So we noticed that 48 past papers had questions related to probability out of a total of 50 random papers that we looked at. So our probability is 48 out of 50, which if we multiply top and bottom by 100, multiply top and bottom by 2, so if we multiply by 2 over 2, that's equal to 96 out of 100, or 96% chance. So I think it would be a good idea for me to learn probability. Okay, so here we have a question taken from an actual past paper. It says the diagram shows information about the scores of Class 3A in a spelling test. And here we have a bar chart showing the frequency against the score. And it says a student is chosen at random from Class 3A. Work out the probability that the student's score was the mode for the class. Okay, I'm not sure. I don't think we've covered mean, mode and median averages yet. But the mode is the average that occurs most frequently. So if we look at our chart here, we can see that the largest bar, the most frequently, is a score of 8, and if that's 8 and that's 10, then this is halfway between 8 and 10, so 9 students scored the mode, which is 8. So we've got 9 students out of a total of, it looks like the question doesn't say how many people were in the class, so we're going to have to count that for ourselves. So 2 people scored 4. And 3 people scored 5. And looks like 6 people scored 6. That's between the 6 and the 8. So 7 people scored 7. And yeah, we already know 9 people scored 9. So our probability is equal to 9 out of a total of, well, 2 plus 3 is 5, 5 plus 6 is 11, 11 plus 7 is 18, 18 plus 9 is 27. If we like, we can cancel that down to a probability of 1 in 3. Although personally I think 9 in 27 is probably better because it gives you a better idea of the sample size. Okay, I hope that was helpful. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.